Assalamualaikum and good evening. Today I'm gonna talk about preventive maintenance and total productive maintenance. Subtopic machine map, downtime record, annual training plan, and overall equipment efficient. My name is Muhammad Harith bin Muhammad Salim, Mathematic VB22029. Meaning of resource. Preventive maintenance and total productive maintenance consists of an explanation of the problem in the industry. It is important to gather related information, collect the fact or data, and try to analyze the fact and reach certain conclusion either in the form of solution. Next, introduction to preventive maintenance and total productive maintenance. Preventive maintenance. Preventive maintenance is a routine, scheduled inspection and task performed on asset and equipment. Why to do preventive maintenance is to ensure your equipment is safe to use, to prolong the life of your equipment, to ensure the product being produced is of the best quality, save money from a major maintenance, to ensure machinery always operating at the 100% efficiency. Preventive maintenance workflow. First, identify asset, set time based or meter based maintenance interval. Time or meter reading is hit, assign maintenance, perform maintenance, and run asset as usual. So basically, when the time or meter is hit, we need to assign the machine to maintenance. Next, 3 types of preventive maintenance. First, time. Approach schedule a preventive maintenance task using a set time interval. Second, users trigger a maintenance action when asset usage hit a certain benchmark. Third, condition. Monitor the actual condition to asset of an asset to determine what maintenance tasks need to be done. Next, total productive maintenance. Total productive maintenance is the process of using machine, equipment, employees, and supporting process to maintain and improve the integrity of production and the quality of system. Total productive maintenance have 8 pillars that based on 5S. The goal total productive maintenance is 0 defect, zero breakdown, 0 accident, and 0 waste. First pillar is autonomous maintenance. Second, focus improve. Third, lean maintenance. Fourth, daily equipment maintenance. Fifth, quality maintenance. Sixth, education and training. 7, TPM in administration. 8, LTE safety and the environment. 5S, the foundation of the 8 pillar. First, sort series, eliminating clutter from the workspace. Second, set in order, set on, ensure order by following a place for everything and everything in its place. Number 3, shine, say so, clean the workspace and keep it that way. Number 4, standardize, seiketsu, standardize all work process, making them consistent. Now, and lastly, sustain, shitsuke, constantly reinforcing the first 4 steps. The total productive 8 pillars. First, autonomous maintenance. Autonomous maintenance means ensuring your operator are fully trained on routine maintenance. So basically, the operator need have some knowledge before doing their work with machine. Second, improve. So focus improve. Improving function and process continually. Focus improve, look at the process as a whole and brainstorm idea how to improve it. You can collect data by observe and ask the operator. For example, Number 3, planned maintenance. Setting metric like failure rate and historical downtime, and then scheduling maintenance tasks. For example, planned maintenance, if you some machine that have been maintained still have a error, like yeah, some part the error need to be changed every 3 months. If you have saw the historical, that so for example this machine have every 3 months the pulley have a crack, so basically every 3 months we need to change the pulley and scheduling. Next, quality maintenance. The quality maintenance pillar focus on working design error detection and prevention into the production process. Next, early equipment management. The TPM pillar of early equipment management take the practical knowledge and overall understanding of manufacturing equipment. So this is like the first one, but this time for the whole plant. For example, the company buy a new machine, so the mechanic, the technician need to know about the machine. So basically, the company will invite the manufacturer machine to brief to them about the machine. Next, training and education. Training and education apply to operator, manager, and maintenance personnel. 7. TPM in administration, supporting production by improving things like order, processing, procurement, and scheduling. And lastly, safety, health, and environment, to produce an environment that makes production more efficient, but it should not be at the risk of an employee safety and health. Next, we go to the machine map. Machine map, identifying, classifying, and charting the physical location all of machine consumable and regular replacement item. Identifying machine access point to perform calibration, adjustment, consumable check, and replacement work. Identifying all lubrication system, pump, server, and lubrication delivery point found on each machine used to fabricate an end user lubrication regime. Identifying all data collection point, identifying all logout and top-up location. Basically, the machine map is same like the early equipment management. They need to know all about the machine. Machine map benefit. Provide an intimate document as both photo essay and location schematic of each machine preventive and condition-based maintenance point that can be used to book a relevant preventive maintenance job task and work instruction. So if machine map that have a blueprint, it's easy to us to choose or detect where the part need to be changed. Book a relevant consumable machine part list. For example, the part that need to be changed, oil filter. So they don't have to buy so many of filter that can take so many storage in the store, took so many space in the store. Facilities training and rapid assimilation of new hire to perform preventive maintenance consistent and correct manner. Enable the development of efficient preventive routing and increase match time effectiveness. Serve an excellent framework from which to build relevant machine preventive maintenance checklist. Next, machine map workflow. First, plan. Under the plan, align the reliability strategy, identical physical asset, prioritize asset by consequence, establish target, perform requirement. After plan, we go to assess, perform analysis, and continual improvement between improve, work identification, and improve, we go to control. Under the control, we have work planning, work scheduling, work execution, and follow-up. And sustain the maintenance loop. So basically, between assess, improve, and control have a same workflow and loop. Next, downtime record. Downtime record. Unexpected or unplanned downtime is the most significant factor that reduces manufacturing productivity and profitability. Collect from both machine and operator in order to run effective downtime analysis, including downtime category, whether the downtime is planned or unplanned, duration of downtime, the downtime occur, the time the downtime occur, the shift or operator running the machine. So basically, this data need to be taken for the analysis later. Downtime record system. This system is from Machinemetric. Downtime Pareto. Pareto bar chart that illustrates downtime for all machines in the environment by category and minute of downtime. Downtime event table that lists all categorized downtime events that have occurred over the selected time period. Downtime by machine. Composite bar chart that illustrates downtime for each individual machine with different color indicating the different downtime categories. So basically, downtime Pareto, this will show us, for example, the minute of downtime, how many times is occur, and the problem. For example, this is material issue, maintenance unplanned, machine alarm, inspection or its process. Let's go to the downtime event. Sort by column. Click any column heading to sort the table in the ascending or descending order based on the data in that column. Click once for ascending, click twice for descending, and 3 times to remove the sort. Textures. The machine, reason, and message column heading contains search field that automatically filter the table data based on the entire in the search field. View machine timeline dashboard. Clicking on any downtime event in the table will open the timeline dashboard for the machine that experienced the downtime event. So basically, this Machinemetric software help many company to track down their downtime record. Next, downtime by machine. View downtime category summary. Hovering over color segment on a bar will provide the summary data for that category on the machine. View machine downtime report. Clicking on the composite bar associated with a machine will open the downtime report page for that individual machine. For example, this downtime by machine is every machine have their record, and the color is the cause of the downtime. So if we click on the bar, they will show the, for example, the unplanned maintenance, the red one. If you click, we saw the record downtime for 4 days, 40 hours, 10 minutes and 57 seconds. Annual training plan. Annual training plan. Effective maintenance is the first line of defense against equipment downtime, productivity issue, safety incident, and other disruptive events. A skill and experienced maintenance workforce ensure that daily operation remain unaffected by technical issue. Annual training, form of training. On-the-job training. Few firms can afford to give maintenance technician time away from the job for training. More effective in skill development when compared to belly class or text-based training. So, on-the-job training, very effective for a junior technician. Many companies have a senior technician, and when if they have a new technician, the junior, they will ask the junior to prepare the machine. Next, workshop. Firm can organize special in-house workshop conducted by certificate trainer. Sometimes this model are conducted by outside contractor or consultant. For example, workshop, if any company that buy a few machine, for example, they they need few machine, and they don't have a knowledge. Basically, they will invite the third party which is the manufacturer machine to brief to them about the machine. Next, AR and VR training. Virtual reality and augmented reality technology are game changer. The software redundant 3D version of machine and part to delivery high immersive practical design without disrupting production on the plant floor. Learning about the maintenance to replicate machinery without the need to dismantle the machine. So there are only few that AR and VR training that we use. Maybe for 5 or 10 more years. Furthermore, for another years more, this training will get more expert. Let's go through the video how the AR and VR training. training plan benefit, increase customer satisfaction, better work environment, internal promotion, enhance organization structure, increase knowledge and skill, improve confidence, less supervision requirement, optimize workflow, standardized process, improve performance. Next, overall equipment efficiency. Overall equipment efficiency, OEE, is a measurement used to determine how efficiently a machine is running. Through the definition implies that OEE is the measure of a particular machine. It can also be used to measure the efficiency of product line, section of a plant, or even the entire plant. Formula for OEE is availability times performance times quality. Next, OEE has a 6 P's loss that divide by 2 for each: availability, performance, and quality. Under availability have a breakdown for downtime, set up and adjustment for a plan for the plan 1. Performance minus stoppage, reduce speed. Quality for the reject and rework. Let's go through. First, plan stop. From the time when equipment is scheduled for production but is not running due to planned event. For example, they need to maintain or cleaning the workspace. Second, unplanned stop, from the time when equipment is scheduled for production but is not running due to unplanned event. Is machine error or breakdown, so it's called unplanned. Next, micro stop, the time when the equipment stops for a very short period of time. Often the operator solves the issue. They can be repetitive, same problem, different day. For example, micro stop, the operator need to reach the tools that they want to lose the nut or something. So it takes time to the operator takes the tools. Next, slow cycle, the time when equipment runs slower than the nameplate. The theoretical faster time manufacture one piece or ideal cycle time. So slow cycle time is basically the, for example, the line is slow from the it should be. For example, the system error, something like that. Next, production reject, defect that have produced during stable production, including those that we can rework as OE measurement, measure quality based on right first time. Startup reject, defect that have produced from the start until stable production. They have occur after any equipment startup. OEE calculation. For example, we have the data that we need to calculate the OEE. First, we have to search the runtime. Runtime is planned production time minus stop time. For example, the planned production is 420 minutes because they minus the breaks. So we got a 42. And Down 47 minutes for the downtime, stop time. And we got the 37 minute, 73 minute. Good count. Good count is a total count and reject count. Total count minus reject count. And we got the 80,849 availability. Runtime divide plan production time. Runtime, we just got the runtime. Runtime divided plan production time. Plan production time, we minus the breaks. For performance, idle cycle time times total count divide run time. For example, the cycle time is in second, 1.0 second. Mine times total count 19,271 divide by runtime 373 times 60 seconds. Why 60 seconds? Because this idle cycle time is in second, so we have to times 60 seconds. Quality is good count divided by total count. Good count means this one. Good count and divide by total count. Total count F this. And after we got the result, we can calculate the OE, availability, time, performance, time, quality. So the OE is 74.79%. Conclusion. In conclusion, maintenance is an important factor in quality assurance. Analysis the data that has been taken to improve from time to time. All this determine the long-term success of company. Terima kasih.